Hello everyone. Visual Basic in Excel is a very powerful tool that allows us to define, create, function, procedure, formulae, and many more in Excel that help us to save a lot of time when dealing with complicated table or massive number in Excel table. In this video, I will demonstrate how to use Visual Basic to create formulae for quantity takeoff, for silo concrete slab, and uh, in addition, I will create a function, a formulae to calculate a unit rate for an in situ concrete with a rotation 1 to 4, so that it helps us to uh, calculate unit rate automatically. In any formulas or function for our shallow concrete slab, I will introduce a little bit about the macros in Excel. Macro is a tool that allows us to copy and repeat what we have done before in Excel, so it will help us to save a lot of time to repeat the same task. So I will click the record macro here, and I create a name for this test, test2 for example, and click OK. And in here I will type test, then I click stop recording, and I want the test appear in any other cell, so I click to this cell. I want to have the word, and then I click to macro and test one and run. You can see here the test word appear here. That is the same I have done before in this cell. Okay, so how can we do this test in Excel? Because the Excel using the uh, programming code called Visual Basic to do their task. Uh, to see what is the cost of this macro, we can click to macro again and click to test 2 and click to edit. We can see here in the right hand side the coding content, and the left hand side the folder and the appropriate menu. So in order to create a function formula for our quantity takeoff, we will have to use this Visual Basic interface. In order to do that, for example, now we want to create the formula for quantity of a silo concrete slab. The quantities a silo, the area is circle area, so it's a little bit difficult to create a formula when we do it in Excel. So I will create in a new function, a new formula in Visual Basic, so that we can use it automatically later on. In here to do that, first we click to I will close this one and do it again so you won't be confused. First, I will click developer and click to Visual Basic. It will appear the Visual Basic interface. So I will click the insert and click the procedure and name. I can say the for example silo cubic, and click this function, change from sub to function here, and click OK. In here, we will define our formula silo cubic, silo cubic was equal b constant that is 314 ham dimension square 2 and divide 4. This is actually the formula for a circle's area, and then the area we will time the technique technique so imagine the cubic quantity for silo concrete slab is with the step of circular. We will calculate the area of circular in time the thickness equal to the cubic meter. So we need to see here why is something wrong here. Okay. Okay. And I will open this one for easily view. Okay, so here we will have to create the argument. The argument is our variable we put into the function. We put dimension here. We can copy and paste dimension, and we say that dimension as double. Double is a variable that allow the dimension can be integer or real or number with routing. So we will choose dimension double, and another argument is techniques also an argument we still say as double, and okay, here we will put here quantity. Now we click equal and silo cubic, the function we have created, and click silo cubic. And now we can is it the same as an Excel function we have already known before. In here we can put the argument here, but I also can do another way to click the insert function, and you see now the function argument appear and it asks us what is the dimension. For example, the dimension is the length, and technique is the width. You can see the new function we have created calculated automatically 47.1. Okay. We can also copy like an Excel formula as usual. Okay. So move on to the unit rate. I want to create a formula for unit rate for concrete in situ with a proportion 1 to 4 1 cement, 2 sand, and 4 cost aggregate. It, it, I will explain a bit here before we entering to the function. First, we can uh, we have some data. The Portland cement per ton is 122 dollars per ton, and the sand is $64 per ton, and cost aggregate is $66 per ton. And here we can break down the unit rate, uh, the components, uh, quantity, price, and amount. Or unit rates I will calculate based on the formula material plus labor cost plus blend cost and plus overhead profit, or I can say OHP. And here breakdown unit rate, component material cost, blend cost, labor cost, and OFB cost. For material cost, 1 cubic meter of cement with a density 1/4 ton per cubic meter. So 1 equal to 1/4 ton for each cubic meter of cement. So I put the quantity for 1 cubic meter cement is 1/4, and price 122 here. You can see I put here. Similarly for sand, 3/2 and 64 dollars per ton. And we also add shrinkage 40% because when we mixed the mixed component, cement and sand and aggregate, it will slump. So that in order to add up, we will add up 40% shrinkage here. You can see 40 shrinkage is equal to the sum of but the cement cost, sand cost, and aggregate cost. And we also add weight 2.5%. 2.5% is the sum of all the cement cost, sand cost, aggregate cost, and shrink cost times 2.5%. And we will have the total cost per 7 cubic meter because 1 cubic meter of cement plus 2 cubic meters of sand and 4 cubic meter of aggregate equal to 7 cubic meter, and with total got $1,069. So we can convert to a material cost per square meter. We can divide total cost per 7 meter divide 7. We can get the material cost for 1 cubic meter, and blend cost per cubic meter for this in situ concrete 1 to 4 is I some $30. And a labor cost, we have to mobilize 4 hour labor with the price per labor $22 per hour. So we times 4 times 22 is equal to 88. The total direct cost, I sum the material cost per square meter and blend cost per square meter and labor cost per square meter. I have the total cost per square meter is 271, and the OFP, the overhead profit, I sum 15%. So the total overhead profit is equal to total direct cost times 15% is equal to $41. So cost per square meter is equal to total direct cost plus overhead and profit is the same with the formula here. Is equal to $311 per cubic meter. So as you can see, we we may take time. It's a time consuming to do this way to come up a unit rate. So in this case, we also can use Visual Basic function to create a, a formulae for unit rate. In case it will be very useful in case we change our price of cement, price of sand, or price of aggregate, or even we change the overhead profit by using our own design function. To do that, we still come back to Visual Basic again, click to Visual Basic, and in this case, I already create a function because it takes time, so I will explain how to create this function for the unit rate. So first we will uh, create the formulae. Unit rate is equal to direct cost plus overhead profit. Overhead profit is equal to direct cost times overhead and profit rate. Overhead profit rate, uh, as we know, we assume 15%. This is a variable we can change 15% or 60%, 20%, depend on us if we use our function. And direct cost is equal to material cost, blend cost, and labor cost. And labor cost is equal to labor hour times labor rate, and blend cost is equal to blend rate. And material cost equal to raw cost plus shrinkage plus weight, and divide 7. Uh, we divide 7 because the proportion is 1 cement, 2 sand, and 4 aggregate. And shrinkage is raw cost times 0.4. Weight is raw cost plus shrinkage times 2.205 or 2.5%. And raw cost is equal proportion cement times 1/4 times cement price plus proportion sand times 1/6 sand price plus proportion aggregate times 1/4 and times aggregate price. Okay. Uh, this although is a little bit complicated, is basically is based based on our previous explanation. So we also specify some argument, Robertson cement as double, cement price double, and Robertson as double. All the argument is the variable that we will have to input, and the dimension, the dim is dimension in memory, raw cost as double, shrinkage, and weight is another variable that will be changed when we input our argument here. Okay, so I will zoom in, and then for the ray here, we can use our new function. We click equal to our unit ray. Unit ray here, you can see unit here, and I will click to insert function again, the icon here, and then Robertson cement. Robertson cement is 1, am I right? 1. And cement price is 122, and Robertson sand is 2, right? And sand price is 64, right? And proportional gauge is 4. We scroll down a little bit, and our gauge price is 66, right? And blend rate here 30. And label hour is 4 hours. Label rate is 22. And overall profit rate is 15%. You can see they already calculated here 311. I click OK. You can see the function formula we have created have the same result with our manually calculate. So that is my sharing for how to use the visual basis in Excel to create our function. Thank you for watching.